Well, hello there, amazing people. You are welcome to this video where we get to see the basics about polyatomic ions in chemical equations. It's been an interesting series thus far, and I hope you're getting massive value for what you're seeing here. So let's get into what we have for today's video. We're looking at polyatomic ions. Now, it's true that the moment students see anything like, SO4, NO3, they begin to panic. Oh, what's this? The equation starts looking advanced. But the truth is, balancing equations with polyatomic ions can become easier if you know one trick. And that trick is this: treat the polyatomic ion like one single group. Treat the polyatomic ion like one single group. I'll explain what I mean in a bit. So the first thing is, what is a polyatomic ion, by the way? A polyatomic ion is simply a word that contains two things: poly and atomic. Poly here simply means multiple, and atomic here simply talks about atoms. So a polyatomic ion is simply an atom with multiple atoms. Is simply an ion with multiple atoms contained. So a polyatomic ion is a group of atoms that stay together and behaves like a single unit. So instead of separating during reactions, they often move together as a group. Here are some examples of polyatomic ions that we have. We have the first one, which is the sulfate ion. It contains the sulfur element and it contains the oxygen element. That's for the sulfate ion. The next one is the nitrate ion. It contains nitrogen and it contains oxygen as well. The third one is the carbonate. It contains carbon and oxygen as well. The fourth one is oxygen and hydrogen. That's the hydroxide ion. And the last one, not limited to all these, but these are just a few examples, is the phosphate ion. Now, these guys can take part in chemical reactions, and if they appear on both sides of the equation, treat them as one group. So, I'll explain what I mean by dealing with a few examples, and then I'll hand over the baton to you. So, we're balancing this chemical equation right now. The first thing I want you to do is to check it out. Are there any polyatomic ions on both sides of the equation? You can see the list I have over here. Now you check out the equation one more time. Are there any polyatomic ions? Yes, I can identify one over here, the sulfate ion SO4. The sulfate ion SO4. So what this simply means is I will treat this SO4 as though it were an element. So let's deal with that. We have CAR. C stands for count, A stands for adjust, and R stands for recount. So I have one column for the element, another column for the left hand side of the equation, and the last one for the right hand side of the equation. So let's identify the elements. The first one we have is sodium, Na. Let me write that down, Na. Now, you can see SO4 over here. SO4, that is the sulfate ion. Let me put that in a bracket so you see clearly. On the left hand side we have it, and on the right hand side we have it. So I will not come and now begin to say sulfur separately and oxygen separately. No. I will deal with them as a group since they are together. That's the essence of having polyatomic ions in chemical equations. The next thing to do would be to move on to the next element, which is barium, Ba. So I indicate that, and then finally I have chlorine, Cl. So can you see how I identified all the things present in these chemical equations, including the polyatomic ion? So for sodium, I have two atoms on the left. Let's write that down. On the right, you can see over here I have just one atom of sodium. So let me indicate that. For sulfate, the sulfate ion, on the left hand side there is just one unit. Okay, you can see it over here. SO4 appears just once. On the right hand side as well, SO4 appears once as well. Then for barium, you can see on the left side one atom, and on the right side one atom. And then finally for chlorine, you have two atoms on the left and one atom on the right. So you can see we've identified the number of atoms for each element present on the left and on the right. So let's start with the first one that is not balanced, which is sodium. I have two atoms on the left and one atom on the right. So to balance sodium, I just simply include a coefficient of 2 here, and this is what the equation becomes. Na₂SO4 plus BaCl₂ yielding BaSO4 plus 2NaCl. Now you can see I have balanced sodium, 2 on the left and 2 on the right. Now remember, at each point of introducing a new coefficient, we need to recount to see that the other elements are balanced. So for sodium, I have 2 on the left and I have 2 on the right. And for the sulfate ion, I have 1 on the left and 1 on the right as well. For barium, 1 atom on the left, 1 atom on the right as well. For chlorine, I have 2 on the left, and this 2 also affects chlorine over here and 2 on the right. So chlorine has already been balanced by introducing the new coefficient. So the full balanced chemical equation now becomes, let me write it down clearly for you to see, Na₂SO4 plus BaCl₂ yielding BaSO4 plus 2NaCl. This, my friends, is the full balanced chemical equation. I hope you got value for that. Let's check out the next equation to balance. Now, at this point, I want to ask if you can identify any polyatomic ion here. Now, if you look closely, you'd find out that there is a polyatomic ion on the left hand side, the nitrate ion NO₃, and it also appears on the right hand side, NO₃. So I will treat it as a single unit. So let's list out our steps. We count, we adjust, and we recount. Count, adjust, and recount. So the first thing to do would be to write a column for the element, another column for the left hand side, and the last one for the right hand side. So allow me to draw the table. So how many elements can I identify? I have Ag, which stands for silver. I have the nitrate ion NO₃. I also have sodium Na. You can see sodium over here. And then finally I have chlorine Cl. Now Ag appears once on the left and appears once on the right. 1 1. The nitrate ion appears once on the left and once on the right as well. 1 1. Sodium appears once on the left and once on the right. 1 1. And then chlorine appears once on the left and once on the right. 1 1. This equation is fully balanced. There is no need to carry out any procedure. Fully balanced and straight to the point. We have the next one on the screen. Now, this time I want your intelligence to be tested. The rule says when a polyatomic ion appears on both sides of the equation unchanged, that is when we treat it as a single unit. But in this case, we have CO₃, carbonate ion, appearing on the left side. But on the right hand side, we do not find it. So that means we will balance it normally without treating that polyatomic ion as a single unit. So we count, we adjust, and we recount. We have count, adjust, and recount. So the first column is for the element, the second one is for the left hand side, and the third one is for the right hand side. So let's write that out. How many elements can I identify? I have calcium, Ca, I have carbon, C, I have oxygen, O, I have hydrogen, H, I have quite a lot of elements here, and I have Cl, chlorine. Now, remember, oxygen is to be left to be balanced at the later stage or for the last concluding stages of balancing a chemical equation. So let's count first. For calcium, I have one on the left, one atom, and on the right side, I have one atom as well, one. For carbon, you can see one atom of carbon over here. On the right hand side as well, you can see one atom of carbon, one. We need to be careful when counting so we don't mix up the symbols. For oxygen, you can see over here there are 3 atoms on the left. On the right, you can see one atom over here and 2. 1 plus 2 gives us 3. For hydrogen, you can see one atom over here and then 2 atoms on the right. 1, 2. And then for chlorine, you can see one atom on the left and 2 atoms on the right. 1 atom on the left and 2 atoms on the right. So you can see that chlorine and hydrogen are not balanced. So we begin with chlorine, since we're saving hydrogen and oxygen for the last. Now, for chlorine, you can see on the left side 1 atom. On the right side, there are 2 atoms of chlorine. So what do? Well, it's quite easy. We change or we introduce a coefficient of 2 in front of HCl. That way, we've changed chlorine to move from 1 to become 2 on the left hand side. That way, we've balanced chlorine. So this is what the equation becomes: CaCO₃ plus 2HCl yielding CaCl₂ plus H2O plus CO₂. Can you see how this is playing out? Pretty easy. Now, the next thing to do would be to recount. For calcium, I still have 1 on both sides. For carbon, I have 1 on the left. On the right hand side, I still have 1. For oxygen, I have 3 on the left. Let's write that out. And I still have 3 on the right. For hydrogen, I now have 2 on the left. On the right side, I have 2. So let's write that out. 2 on the left, 2 on the right. And then for chlorine, I now have 2 on the left and 2 on the right. So the equation is even fully balanced. CaCO₃ plus 2HCl yielding CaCl₂ plus H2O plus CO₂. This, my friends, is the fully balanced chemical equation. If you're getting value for this, please consider liking, sharing, subscribing for more content coming your way every day of the week. So here is something to bear in mind: treat polyatomic ions as one group only if they satisfy one condition, and that is they stay unchanged on both sides. If the group breaks apart, then count the atoms normally, just like we saw in the previous examples. So here are some practice questions I'd like you to try out your hands on. Solve them and drop the answers in the comment section, where I'll be waiting to respond to every tidbit that you drop in. And up until next time, where we get to see deeper concepts of balancing chemical equations, my name's David. Stay blessed.